Okay friends, so this is my second lecture on this topic, sequence of real numbers. So in the last we have seen the sequences, that is preliminaries of sequences, that is when we say the sequence is convergent, divergent or oscillator. I have taken some examples also. Today we start the next point on this from this chapter, sequences of real numbers. Important one, that is bounded sequences. So bounded sequences. Bounded sequences. So there are two types of bounded sequences, bounded above and bounded below. Okay. So first we learn the bounded. This is short form. BDD means bounded above sequence. What is the definition of bounded above sequence? Before the definition, we take an example. That is, which one is bounded above, below, and bounded sequences. So, bounded above sequence. So, consider the sequence Sn. Sequence Sn, bracketed Sn means sequence Sn. Consider this is sequence N. Sequence N. You know the terms in the sequence 1, 2, 3, dot, dot, dot in this way. So, is this sequence is bounded above or not, bounded below or not? We have to learn this one. This is an example. That is sequence N. Okay. Can we find a number M, an integer, whatever in that, or real number M? Can we find a real number M such that each term of the sequence is less than M? This is not possible in this case for this sequence. We can't find the number M such that Sn is less than M. Okay, so take down any number, any term in the sequence Sn. So can we find number M such that Sn is less than M? This is not possible. So this sequence is not bounded above sequence. Okay. Now, but we can find a real number M such that Sn is greater than equal to that small m. And that number is 1 in this case. That is, this small m is equal to 1 and this 1 is less than each term of the sequence Sn. So we say that the sequence Sn is bounded below sequence. Okay. Now we take another example. So sequence Sn means suppose 1 upon n. 1 upon n. We know the terms in the sequence. So 1, 1 by 2, 1 by 3, 1 by 4, dot, dot, dot in this way. Now, when we say the sequence is bounded below or bounded above, okay, see, this is an important example. So, we know that this term 1 is greater than each term of the sequence. We write in this way, for all n belongs to n. The meaning of n belongs to n means take down any n from this Sn. This Sn is less than or equal to 1. So in this case, we say that this sequence is bounded above by 1. That is, Sn is less than this capital M, and capital M means 1 here. Okay. So the sequence Sn is bounded above. Now, is this sequence is bounded below or not? We have to check it. So see clearly, Sn means any term in this Sn is greater than 0. Am I right? Each term is greater than 0. So we can say that the sequence Sn is bounded below also. So see, this is an example of a bounded sequence. The sequence 1 upon n. Sequence 1 upon n is bounded above by 1 and bounded below by 0. See that 0 does not belong to that 0, the term 0 is not in the sequence. but Sn is greater than 0. So Sn is less than equal to 1, Sn is greater than 0, Sn is less than equal to 1, meaning of that is each term in the sequence is less than equal to 1. So this is bounded above by 1. And each term in the sequence is greater than 0. So we can say that it is bounded below by 0. See the definition now. Definition of the bounded above sequence. These are the short form actually. BDD stands bounded. Okay. So what is the bounded above sequence definition in this way? So consider the sequence Sn. Sn is the sequence of real numbers. Okay. The sequence Sn is said to be bounded above if there exists a number k such that Sn is less than equal to k for all n belongs to n. For all n belongs to n. Now see, what is this actually? That is, each term in the sequence is less than that number k. If we find such number k, that is Sn is less than equal to k, then we say that the sequence is bounded above sequence. So, example, we have taken the example, that is, this is an example of bounded above sequence. Now see, what is this actually? Sn is 1 by n. We can find the number 1 such that this Sn is less than equal to 1. So we say that the sequence is bounded above sequence. Okay, am I right? Now see this one, definition of bounded above sequence. A sequence Sn is said to be bounded above if there exists a number k such that Sn is less than equal to k. This is bounded above sequence. Now see the definition of bounded below sequence. Bounded below sequence. Okay, see the definition of bounded below sequence. Consider the sequence Sn. Okay, a sequence Sn is said to be bounded below if we can find the number m, small m, such that Sn is greater than equal to that number small m for all n belongs to n. See the definition of bounded below sequence. If sequence Sn is said to be bounded below if there exists a number small m such that Sn is greater than, each term in the sequence is greater than that number m, small m. Okay, then we say that sequence is bounded below. Now, if a sequence, any sequence Sn is bounded above and also bounded below, then we say that that sequence is a bounded sequence. Okay, so definition of bounded sequence. So bounded sequence, the definition is, if sequence Sn is bounded above and also bounded below, okay. If the sequence Sn is bounded above and also bounded below, then sequence is said to be bounded sequence. Sequence is said to be bounded sequence. Example, a well-known example is the sequence Sn, which is equal to 1 upon n. We know the terms in the sequence, that is 1, 1 by 2, 1 by 3, dot 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 in this way. Clearly, we know that sequence Sn is less than equal to 1. That is, each term in the sequence is less than equal to 1 and greater than 0. Okay, so this is for all n belongs to capital N. That is, take down this n from this n. That is S1, S2, S3 in this way actually. That is, take down any term in the sequence. That term is less than equal to 1 and greater than 0. In this case, we say that the sequence 1 upon n is bounded sequence. Is bounded sequence. Do you get it? Okay, what is meant by bounded sequence? So, see, once again, these tools, that is, when with the sequence is said to be bounded sequence, bounded above, bounded below. Here is the example, okay. So we take the next point now. This is the bounded below, bounded above and bounded sequences. One more thing is a sequence Sn, that is one more definition. Sequence Sn is said to be bounded if modulus of Sn is less than some number m, okay, for all n belongs to n. Modulus of Sn is less than m. Now what is this modulus? You know that modulus of Sn is less than m. The sequence Sn is said to be bounded if modulus of Sn is less than m. We know that modulus of Sn, meaning of that is Sn is greater than minus m and less than small m. That each term of the sequence is greater than this minus m and less than small m. That is, Sn is bounded above by m and bounded below by minus m. Then in this case we say that sequence Sn is a bounded sequence. This is one more definition of bounded sequences. Okay. Next is the examples. We take examples. Suppose the first example, that is sequence Sn is equal to n only n. We know the terms, that is 1, 2, 3 dot 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 in this way. Clearly we can't find a number k such that each term in the sequence is less than that number k. So the sequence is not bounded above. But we know that Sn is greater than or equal to 1. This is for all n belongs to n. So we say that the sequence Sn is bounded below by 1. Okay, bounded below by 1. One more example of the sequence Sn is equal to minus n, suppose, minus n. The terms in the sequence are minus 1, minus 2, minus 3 dot 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 in this way. Now see, this is sequence n which is bounded below. See now the sequence minus n, the terms are minus 1, minus 2, minus 3 dot dot dot. Clearly Sn is less than or equal to minus 1 for all n belongs to n. Okay, that is minus 2 is less than minus 1, minus 3 is less than minus 1. So minus 1 is the greatest number in this case. So this sequence is bounded above. The examples, the sequence minus n is bounded above. Sequence n is bounded below. Okay. Now one more example we take it, that is the sequence minus 1 raised to n. Sequence minus 1 raised to n. Sequence Sn is minus 1 raised to n. The terms in the sequence are in this way: minus 1 plus 1, minus 1 plus 1, dot 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 in this way. Now clearly see the sequence. Each term in the sequence Sn, each term in the sequence is less than equal to 1, greater than equal to minus 1. Am I right? So this sequence Sn is bounded sequence. This is bounded sequence. So sequence minus 1 raised to n is a bounded sequence. So I think you get the clear idea about the bounded above, bounded below and bounded sequences. There is one theorem, that is sequence of real numbers is convergent, then sequence Sn is bounded. Okay, that is, if sequence Sn is convergent, then it is then the sequence Sn is bounded sequence. This is the theorem. We are not going to prove this one. We have to remember as it is. So what is the meaning? I will explain first. Sequence Sn is convergent, then it is bounded. Then it is bounded. What is meant by convergent sequence? You know that. Okay, now in the last that is a lecture we have seen sequence Sn is convergent means what? Okay, convergence means what? That is first of all we take an example of convergent sequence. That is sequence 1 upon n. That is 1, 1 by 2, 1 by 3 dot 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 in this way. Is this sequence 1 by n is convergent or not? See, if terms are going larger and larger. That is 1 upon 1 lakh, the term is in this sequence. Okay? But 1 upon 1 lakh, am I right? 1 upon 1 lakh is approximately equal to 0. This is a very small number. Positive but very small number. So this is nearly approximately equal to 0. In this case, we say that sequence 1 upon n is convergent sequence. Okay? That's why it is convergent. And we write as limit of 1 upon n as n tends to infinity is 0. We have seen that we know that any number upon infinity is 0. But how it is 0? See, that is important one. As n tends to infinity means if n is a very large number, then this is 0. So we say this is the convergent sequence. This is convergent sequence. Now, one more. Sequence n. Sequence n, that is Sn is sequence n. It is equal to 1, 2, 3 dot in this way. This is not convergent sequence. That is limit of Sn as n tends to infinity means limit of n as n tends to infinity. If n is a very large number, this n tends to infinity means limit of n is infinity. So this is divergent sequence. We say therefore sequence Sn means sequence n is divergent sequence and diverges to infinity Sequence minus n means minus 1, minus 2, minus 3 dot. In this case, for this sequence, limit of Sn as n tends to infinity means limit as n tends to infinity of this minus n is minus infinity. This one is also divergent and diverges to minus infinity. So convergent, the example of convergent sequence, divergent sequence, okay, and we know oscillatory sequence means minus 1 raised to n, sequence minus 1 raised to n. Okay, if sequence Sn is minus 1 raised to n, the terms we know, I will repeat it, dot in this way. What is the limit of Sn? What is the limit of Sn as n tends to infinity? It is plus or minus 1. This is not fixed. Okay, that's why this sequence minus 1 raised to n is not convergent. Limit is not fixed. It may be plus 1 or minus 1. That's why we say that this sequence is a oscillatory sequence. This is oscillatory sequence. So we have taken the example of convergent sequence, divergent sequence and oscillatory sequence. Now there is the theorem is where it goes. Okay, no problem. We take it. That is, if sequence Sn is convergent, this is CGT, short form of convergent, then sequence Sn is bounded. So this is theorem. We accept this as it is. We are not going to prove this one. Okay. Converse of this is not true. Converse of this is not true means what? If sequence Sn is convergent, then it is bounded. But if Sn is bounded, then sequence Sn may or may not be convergent. The example for that is the sequence minus 1 raised to n. Sequence minus 1 raised to n is bounded. We have seen just is bounded sequence. So if it is bounded, but we know that this is not convergent, this is an oscillatory sequence. So see, the converse of this theorem is not true. If Sn is convergent, then that is bounded. If sequence is bounded, then it may be or may not be a convergent. The example of this is in this way. Okay.